So it will collide with each other as well as with the walls of the container. So in order to keep pressure constant, the volume of the gas should increase. Pressure will increase. So if you heat the molecule will, kinetic energy of the molecule will increase. The molecule will collide with each other as well as with the walls of the container. So the pressure will increase. So here we are keeping the pressure constant. So in order to maintain constant pressure, so the volume will increase. Now the distance between the particles will increase. So the pressure remains constant. So when you heat that molecule, so volume increases. So volume is directly proportional to temperature. That is called Charles law. So increase the temperature, volume increases. So volume is directly proportional to temperature at constant pressure. So it will collide with each other as well as with the walls of the container. So in order to keep pressure constant, the volume of the gas should increase. Pressure will increase. So if you heat the molecule will, kinetic energy of the molecule will increase. The molecule will collide with each other as well as with the walls of the container. So the pressure will increase. So here we are keeping the pressure constant. So in order to maintain constant pressure, so the volume will increase. Now the distance between the particles will increase. So the pressure remains constant. So when you heat that molecule, so volume increases. So volume is directly proportional to temperature. That is called Charles law. So increase the temperature, volume increases. So volume is directly proportional to temperature at constant pressure. So we know that V is directly proportional to T, or when pressure and the number of moles are constant. So V is equal to, so K into T into T, the absolute temperature in Kelvin. So absolute temperature, not temperature in Kelvin. So V is equal to K into T. So what is K? So K is called Charles law constant. So what is Charles law constant? So நமக்கு வந்து தெரியும் gas equation PV is equal to nRT, ideal gas equation. So இதுல இருந்து P வந்து என்னது nRT by V. So now we can write volume. So what is volume? So volume is equal to nRT by P. So now you compare this equation and this equation. So name this as equation 1 and this is equation 2. So now when you compare this volume on the left hand side, so here temperature is there, temperature is also there. So now K, this K, it is equal to this nR by P. So it is V is equal to KT. So similarly here also V is equal to KT. So K, what is K? K is nR by P. So the Charles law constant. So what is K? K it is called as Charles law. Charles law constant. So it is nR by P. So K is equal to nR by P. So Alexander Charles. So he only stated this law. At constant pressure, the volume of a given mass of a gas is directly proportional to its absolute temperature. So V is proportional to T, or V is equal to KT, or V by T is equal to K. Or we can write like this. So Boyle's law. So Charles law, but we can write V1 by T1 is equal to V2 by T2. Or we can write, so V1 by V2 is equal to T1 by T2. So like this also we can write V1 by V2 is equal to T2 by, or we can also write like this, T2 by T1 equal to V2 by V1. So different ways we can write this formula. V1 by T1 equal to V2 by T2, or T2 by T1 equal to V2 by V1. So this diagram shows how the volume, it changes with temperature. So here we are keeping pressure constant. So this is the instrument which measures the pressure. So pressure is kept constant. So here we are increasing, pressure is kept constant. We are heating. So we are heating the gas molecule. So when you are heating the gas molecule, the volume increases. So volume is directly proportional to temperature. So when you increase the temperature, the volume of the gas increases. So now the hydrogen gas is in a vessel at constant pressure. So this is the hydrogen gas. So which is at 0 degrees. So now we are increasing the temperature to 1 degree. So now the volume has increased. So now this is the volume. And now this is the volume at 1 degree. So volume increases. So volume increases. So now from 1 degree, we are increasing the temperature to 2 degrees. So again, the volume increases. So there is another statement for Charles law. So now we are saying for every 1 degree rise in temperature, so volume increases. So volume increases. How much volume increase? What is the increase in volume? So that is given by another statement. For a fixed amount of gas at constant pressure, so the volume of gas increase or decrease. When you heat the temperature, volume increase. When you decrease the temperature, volume decrease. So volume of gas increase or decrease by how much it decrease? So it decreased by amount 1 by 273 of its initial value at 0 degree. So for example, so at 0 degree, so you assume that V naught is the initial volume. So now when you increase the temperature, the temperature increases by 1 by 273 of its initial value at 0 degree. So what is the initial value at 0 degree? V naught. So this much is the increase. So V naught by 273, this is the increase in volume. So increase in volume. So now at T1, what is the volume? So original, this is the increase. So initial volume is V naught. So V naught plus 1 by 273 into V naught. So now this is the new volume at V1. So at 1 degree. So originally at 0 degrees, this much volume was there. So when you increase the temperature increases by 1 by 273 of its initial value. So this much is the increase. So original value plus increase will give you the new volume V1. So the volume of a gas at 0 degrees, we are considering this as V naught. So now by 1 degree we are increasing. So when you increase the temperature by 1 degree, the temperature increases by V naught, 1 by 273 of V naught. So this is original value. So now this is the final volume. So now from V1 degree to 2 degrees. So now this is the initial value. So V naught plus V naught by 273 plus. So now the increase will be V naught by 273. So now this you add, now it will be V naught plus 2 V naught by 273. So when you increase the temperature by 2 degrees, we have to multiply by 2. So if you increase the temperature by T degrees, you have to multiply by T. So V naught plus V naught by 273 into T degrees. So this is the increase in volume for 0 degrees, 0 to 1 degree. So this is the increase for 1 degree. But we have increased the temperature for T degree. So multiply by T. V1 degree C is equal to V naught plus V naught by 273. So suppose 5 degree means V 5 degrees is equal to V naught plus V naught into 5 by 273. So this is the increase in the volume. So 0 degree, this is the increase. So final volume, so initial volume, increase in volume. So 1 degree to 2 degrees, V2 is equal to V1 plus the increase in the volume. So V2 plus, so V2 is equal to, so this is V2. So V2 is equal to, this is from directly from 0 to 2 degrees. So this is from 1 to 2 degree. So it is V1. So this is from 0 to 2 degree. So it is V naught. This we are multiplying by 2 times. So V5 means V naught plus 5 times. So similarly for T degrees, it is V naught plus T degree by 273 into V naught. So T naught. So Vt is equal to V naught into, so T by T naught. So V naught into T by T naught. That is Vt. Or Vt by T is equal to V naught by T naught. Or V is directly proportional to temperature. So volume is directly proportional to temperature. So when the temperature is minus 273 degrees. So what is the value for Vt? So Vt is equal to V naught plus V naught by 273 into Vt. So into T. So into T degrees. Okay. So this is the general formula. So now we are keeping the temperature as minus 273 degrees. So it is V naught plus V naught by 273 into, so temperature is minus 273. So 273 will cancel. So V naught minus V naught, it is 0. So volume at minus 273 degrees is equal to 0. So this is called as absolute volume. So volume of a gas is 0. It does not exist as a gas. So all the molecular motion will stop at 0 degrees. Substance cannot exist as a gas. All the molecular motions will stop. So volume is 0. So this is called as minus 273. How can the volume of a gas be 0? So at 0 Kelvin, so or minus 273 degrees. So when 0 Kelvin, the molecular motion stops. So the molecular motion stops. So the gaseous state does not exist. Hence the volume of the gas is 0. So gas just changes to liquid form or solid state. So gas changes to liquid state or solid state. So at 0 Kelvin, all the molecular motion will stop. So the gaseous state does not exist. Hence the volume of gas is 0. So when you are plotting volume against temperature, so now this graph, so here we have to see volume is directly proportional to temperature, or V is equal to K into T. So K2 into T. So now volume is plotted on the y-axis, temperature is plotted on the x-axis. So now this graph, it is like the form y is equal to mx. So it is a straight line. So it is a straight line passing through origin. So the graph should be a straight line. So passing through origin. So now the slope will give you the value of K2. So slope will give you the Boyle's law constant. Slope will give you the Boyle's law constant. So now we are plotting volume against temperature. So at temperature increases, this is a graph at a different, so here, so when you increase the temperature, so volume also increases. So for this is at particular temperature. So when you increase the temperature, volume also increases. So now this graph is for different pressures. So it is at one particular pressure. This is another particular pressure. So we are plotting the graph. So but it is not passing through the origin. So here it is not passing through the origin. So because what is Charles' law? So volume is directly proportional to the temperature should be in absolute temperatures. Temperature should be in Kelvin. So here it is not Kelvin. So it is only in degrees. So we are extrapolating the graph. So to minus 273 degrees. So we are extrapolating the graph to minus 273 degrees. So now it meets it is 0. So this is the origin. So now this becomes the origin for this graph. So now the origin, now here this is the origin. So the volume is plotted against temperature. So this is the case where minus 273 Kelvin degrees. So volume occupied by the gas is 0. So the gas does not exist in gaseous state. It is converted into liquid or gas. So now we have to see. So now this is a Charles' law curve. So it is called as isobar. This graph, it is called isobar. Why isobar? Because pressure is kept constant. So pressure is kept constant. So it is called isobar. So P1 is high or P4 is high. How to find out? So we know that so pressure is inversely proportional to volume. So from this is Boyle's law. So Boyle's law, we know pressure is inversely proportional to volume at constant temperature. So at constant temperature. So now we are going to keep temperature as constant. So when temperature is constant, so pressure is inversely proportional to volume. So now this is the volume. So it is V1. So volume V1. So now volume is higher. Then so this is V2. So this is V3. So this is V4. So now V1 volume is high. So that means the corresponding pressure should be, pressure is inversely proportional to volume. So volume is less. So volume less. So that means pressure should be high. So P1 is low pressure, then P2, then P3, then P4. So V1 is high volume, V2, then V4. So P3 is greater than P2, then P1. So either correct the P1 is less than P2, then P3. So either correct So you should know. So when the temperature is kept constant, so volume is inversely proportional to pressure. So here volume is high, so that means pressure is low. So P3 is low, then P2, then P1. So this you should know how to identify whether it is high temperature or low temperature. So this is the graphical representation of the Char's law. Volume decrease when temperature decrease. So the graph should be a straight line. So but it வந்து decreaseல இருக்கிறதுனால straight line இல்ல. So they extrapolate to origin. So the isobar, so at constant pressure. So the graph it is drawn between volume and temperature at constant pressure. Take down this question, calculate and tell me what is the answer. A toy balloon can occupy 500 ml at 27 degrees. The stretching capacity of balloon is 3 times its volume at 27 degrees. The temperature above which the balloon will burst if pressure of the balloon remains constant. So in the temperature la the balloon வந்து burst ஆகும்னு கேக்குறாங்க. So வந்து D1 கொடுத்திருக்காங்க 500 ml. So T1 கொடுத்திருக்காங்க. So 27 degrees. 27 plus 273. So 300 Kelvin. So the temperature above which balloon will burst. The stretching capacity of the balloon is 3 times its volume. So if V2 1500 ml. Stretching capacity is 3 times its volume. The temperature above which the balloon will burst. So what is T2 கேக்குறாங்க. So நமக்கு தெரியும் V is directly proportional to T or V by T is a constant. So V1 by T1 is equal to V2 by T2. Or we can write T2 by T1 equal to V2 by V1. So T2 கண்டுபிடிக்கணும். So T1 is 300. So V2 1500. V1 is 500. So it is 3 times. So T2 will be 300 into 3. So answer is 900 Kelvin. So if the temperature is greater than 900 Kelvin, the balloon will burst. So T2 by T1 so V1 by T1 எப்படி வேணா போடலாம். So answer 900 Kelvin. So 500 by 300, 1500 by 2. So answer 900 Kelvin. When the temperature is greater than 900, the balloon will burst. So next question, in terms of Char's law, explain why minus 273 is the lowest possible temperature. So இதுதான் lowest possible temperature. So at 0 Kelvin, volume will be 0. So below this temperature, the volume will be negative. Volume cannot be negative. So this is the lowest possible temperature. You tell me the answer for this question. According to Char's law, at constant pressure, which is proportional to temperature. What is isobaric process? Pressure remains constant. Next is Gay-Lussac's law. The pressure is directly proportional to temperature. So pressure is directly proportional to temperature at constant volume and number of moles. So Gay-Lussac's law. So pressure increases. So pressure increases. So the molecules will collide with each other and it collide with the walls of the container. So it exert more pressure. So pressure increases. So when you heat the gas molecule, the pressure increases. So here the collision is less. See here 1, 2, 3, 4, 5, 6. So here much more collision. So due to collision, so the pressure of the gas increases. So increasing temperature, increase in more molecules hitting the walls of the container. So it indicates increase in pressure. So at constant volume and number of moles, the pressure is directly proportional to temperature. So Joseph Louis Gay-Lussac states that at constant volume is kept constant. The pressure of a given mass of the gas is directly proportional to absolute temperature. What is absolute temperature? Absolute temperature. Temperature should be in Kelvin. So pressure is directly proportional to temperature. Or P by T is a constant. So we can write P1 by T1 equal to P2 by T2 equal to P3 by T3. So Gay-Lussac's law. So it states that at constant volume and the number of moles, the pressure of a fixed amount of gas is directly proportional to temperature. We will continue in the next class.